So randomness is this thing that I really harp on, and it's why I spend so much time on the simulations, and I think it's important. But why is randomness so important, right? Oops. Well, it underpins everything we do in inferential statistics. It's really the reason why inferential statistics works. What we are saying when we take a simple random sample, that if it meets certain criteria, then it will look like the population, okay? If our sample looks like the population, we can infer things about that population from the sample. And it really works, okay? I'm actually going to use a simulation to help you visualize this concept, all right? So I'm going to go over here, and what I did in StatCrunch was I did 10 simulations of 20 die rolls. And so this is just a 6-sided die, so the values go from 1 to 6, all right? And what I want to do is I want to look at what the histogram looks like for all of these. If I start at 1 and I have a bin size of 1, I'm going to put the value over the bars, and what I want to do to be able to compare is I'm going to put 2 histograms per page. And I'm going to click compute. And so here are die rolls 1 and 2. And if you can look, I would expect to have equal numbers of 1s, 2s, 3s, 4s, 5s, and 6s. That's what I would expect. I did this random sample, but I don't really have equal numbers. Notice they don't vary too much. They're between 2 and 5. There's not a lot of variability there, but they are not really uniform. This one looks kind of normal, right? This one is crazy where I have 6 values of 1, 4, and 6, right? This one's kind of crazy. This one is fairly uniform. Again, you're between 2 and 5. This one is mostly between 2 and 5 with 1, 1, and 1, 6, okay? This one, again, is between 2 and 6, right? With no values of 5. So you can see it's not really very uniform, right? But there is a little bit of uniformity in at least the values. Why is this? Well, this is simply because I only rolled it 20 times, and that's not a very large sample size. And so it's not looking very uniform. What happens if I made it a little bit bigger? So what I did here was I did 10 simulations again, but instead I rolled the die 100 times. I did it 5 times as much, right? And so now when I go to the histogram and I look at the starting at 1 and going by 1 and putting the values over the top, and again comparing some of the histograms, and I click compute, look, this one is a little off, but look how close this one is to being uniform, right? If you have 6 values and you roll it 100 times, you would expect between about 16 and 17 values of each of the numbers. And look, you've got 16, 17, 18, 19, and 113. Look how uniform that looks. This one's a little off. I go and I do it again. Look, 17, 17, 18. One's a little low, one's a little high, right? 17, 15, 18, 18 with one a little low and one a little high. As I keep looking at it, look at this one. 16, 16, 16, 16, 16, and a 20. 16, 14, 16, 16, 16, 22. Look at how uniform those look. Look at this one, right? 16, 18. I got a couple low and a couple high, but 14, 14, 16, 17, and then this 20 over here, right? 16, 15, 17, right? With one low and one high, right? 17, 17, 15, and so they're not perfect, but look at how close they are to being very uniform to what is going on, right? To what the population should actually look like, all right? And so it does. It really works. And so now sometimes the random samples that meet the criteria can still be different than the population, which is what we saw in some of those histograms. That is why we never state things definitively, right? We express only a level of confidence in our conclusions. But because a simple random sample that meets criteria usually looks like the population, we can be really confident in our inferences. This is why when a sample does not look like we thought it should, we actually draw new conclusions about the population, that things have actually changed. We believe the sample does actually look like the population, and what we thought about the population is actually now different, that things have increased or decreased or changed over time, or because of an experiment or some other influence. And that's why this sample looks different. And this is really important. Okay? And so that's why we study randomness.